Welcome to episode 445 of AI Brief. Today, we are taking a deep dive into some just massive shifts happening right now. We're looking at potential workforce reductions over at Meta to fund these towering AI infrastructure ambitions.
Plus, we are exploring major leaps in physical robotics. Everything from autonomous living room navigation to a very costly vacuum hack.
And finally, we will run through a rapid-fire breakdown of the top trending tools designed to completely automate your daily digital workflows. I mean, the physical and digital boundaries are blending at an astonishing rate right now.
They really are. We are watching software-optimized multi-billion-dollar data centers while simultaneously watching physical machines learn to navigate the absolute chaos of a human living room.
The separation between the digital agent and the physical robot is just vanishing. And if you look at the macroeconomic shift happening at the very top of the tech world right now, it is driven entirely by the demand for this exact kind of infrastructure.
The scale of the capital reallocation it is difficult to overstate. Meta is preparing for major workforce reductions, specifically to offset massive infrastructure spending.
The numbers are staggering. Meta is looking at potentially impacting 20% or more of its nearly 79,000 employees.
Which is roughly 15,800 to 16,000 jobs.
Right. Now, officially, Meta spokespeople classify this current reporting as speculative. But if you look at the underlying math of their ambitions, a massive change in operational expenses is basically inevitable.
The driving force is a planned $600 billion investment in data centers by 2028.
Wait, $600 billion? By 2028?
$600 billion. That requires an entirely new financial posture. You have to locate that capital somewhere within the existing business structure. To compete with other tech giants for frontier model capabilities, they have to secure the compute power right now.
Because data centers, specialized cooling systems, dedicated energy grids, those take years to build.
Exactly. And they are also executing a highly aggressive talent acquisition strategy at the same time. They are reportedly offering multi-million-dollar packages for top researchers to build what they are calling a superintelligence team.
Alongside this, they are actively acquiring platforms like Moltbook.
The acquisition of Moltbook is a crucial indicator of their strategy. Moltbook is designed specifically for AI agents,
which signals a pretty distinct pivot from purely developing foundation models, like a standard chatbot, to developing the orchestration layers where those models actually execute tasks.
An orchestration layer is essentially the management system. It tells different specialized AI agents how to work together, hand off data, and complete a complex project without human intervention. They are buying the infrastructure to put agents to work internally.
So this restructuring would be the most significant since their 2022 to 2023 year of efficiency, which eliminated around 21,000 roles. But the business logic relies on a massive assumption. By reducing headcount, they are betting that these internal tools will automate a significant portion of their own digital work. They expect to maintain or even increase productivity with 20% fewer people.
The internal automation is the lever they pull to survive the construction phase of those data centers. They are banking on the assumption that productivity gains from customized coding assistants and automated workflows will compound faster than the organizational friction caused by losing a fifth of the workforce.
It feels like laying down thousands of miles of railroad tracks right now, hoping the trains they invent next year will eventually pay for it. I mean, the projected efficiency gains of internal AI-assisted operations are entirely hypothetical at this scale.
It is a gamble, certainly.
Does a customized coding assistant or an automated internal workflow realistically offset the immediate, tangible cost of a $600 billion upfront infrastructure build and the loss of 16,000 human employees?
The capital expenditure is a defensive necessity. If they wait for the trains to be fully profitable before building the tracks, they lose the race entirely. They are building the infrastructure required for models to navigate complex, multi-step digital environments autonomously.
That ambition to use technology to navigate complex digital environments perfectly mirrors what is happening right now in the physical world. Let us actually slow things down a bit for this next part, because the sheer physical weight and complexity of robotics requires a more measured look.
It is a totally different ballgame. The translation of these capabilities into physical space introduces an entirely new set of variables. In the digital realm, rules are absolute.
But in the physical realm, you have to account for unpredictable geometry, gravity, changing lighting, and just the sheer physical weight of real-world objects.
Take Figure's Helix O2 home robot. It has officially graduated from basic kitchen tasks to tidying an entire living room autonomously.
A living room is a highly complex environment. You have soft couches, glass tables, scattered items, and unpredictable floor plans that change every time someone moves a chair.
The technical achievement here is rooted in their general-purpose neural architecture. Previously, robots relied on heavily scripted, pre-programmed paths.
So if a chair was moved 2 inches to the left, the robot would just fail?
Completely.
Yeah.
But the Helix O2 is processing visual data and making real-time spatial decisions. Squeezing through tight gaps in furniture requires dynamic proprioception.
Proprioception meaning it knows where its limbs are.
Yes, the robot must understand the exact dimensions of its own physical body in relation to the continuously changing physical space around it, much like a human does instinctively.
This demonstrates that scalable humanoid capability is arriving much faster than anticipated. We are moving from highly controlled laboratory settings into the chaotic geometry of a human home.
But researchers at the Technical University of Munich have built a completely different kind of system. They developed a robot dedicated entirely to finding your lost stuff.
The German researchers approached physical automation through a hyperspecific lens. Rather than building a humanoid to do everything, they built a specialized unit that utilizes 3D vision to build a centimeter-accurate spatial map of a room.
It is not just looking at the room through a camera. It is mathematically modeling the environment in real time.
The mechanism is fascinating. Once it builds that map, it uses the model to calculate the most likely spots for missing items. It does not just wander around aimlessly.
So if you were looking for keys, it calculates the probability of keys being on a table versus the floor.
Exactly. This method operates 30% more efficiently than a random search. The next iteration will even be able to open drawers and cupboards.
This relies entirely on semantic understanding. The system must understand what an object actually is to deduce its logical location within human habitats. It has to connect the visual data of a cup to the geometric data of a coffee table, rather than just seeing two shapes intersecting.
I look at the landscape and I have to challenge the economics of this. Are we really heading toward a future of one general-purpose humanoid-like figure doing absolutely everything in the home?
You think we might go a different route?
Why would anyone spend $50,000 on a humanoid to find their keys when a $200 specialized mapping bot does it perfectly? It feels like our living spaces will be dominated by a swarm of hyper-specialized robots communicating with each other, not one expensive humanoid.
The trajectory of technology often favors modularity initially, followed by consolidation. You are correct that we will see specialized robots dominating the short term because their compute requirements are dramatically lower and their success metrics are narrow.
A vacuum just needs to map the floor. A finder bot just needs to scan surfaces.
However, as general-purpose neural architectures mature and hardware costs drop, maintaining a single humanoid form factor becomes more economically viable than purchasing, charging, and repairing 10 different specialized machines.
Well, speaking of specialized machines, we have a completely unexpected intersection of consumer robotics and cybersecurity. An engineer named Sami Asdufal attempted to steer his DJI Romo vacuum using a PlayStation controller.
As one does.
Naturally. But in the process of tinkering with the vacuum's local network connection to make the controller work, he accidentally exposed a network of 7,000 DJI Romo vacuums to remote access.
This highlights the fragility of the Internet of Things architecture. Consumer robotics often prioritize seamless user connectivity over robust network segregation.
By attempting a localized hardware modification, he inadvertently bypassed the cloud authentication layer that secured thousands of other deployed units. The vacuum's local pathfinding system was improperly shielded from its wide-area network protocols.
DJI patched the flaw immediately and paid Asdufal a $30,000 bounty.
Which is a massive corporate turnaround for DJI. In 2017, they notoriously botched a vulnerability disclosure and heavily alienated the security community. Paying out a swift $30,000 bounty shows a mature integration of cybersecurity practices into their consumer robotics division.
If we connect all these physical systems together, you see the overarching shift. Models are fundamentally changing robotics from deterministic systems into agents with true spatial understanding.
The Helix O2 navigates an unstructured room. The TUM robot builds a semantic probability map. Even the DJI vacuum relies on dynamic pathfinding, which is exactly the system the engineer was trying to hijack with his controller.
So we're moving from pre-programmed paths to genuine spatial reasoning.
Let us accelerate the pace again and transition from robots navigating physical rooms to tools navigating digital workflows. We have a rapid-fire breakdown of today's top trending tools that you can deploy right now to boost your productivity.
These tools represent the immediate, practical application of the automation trends we just discussed. They are bringing orchestration and agentic capabilities directly to the consumer level.
First on the list is Agent 37. This provides your own OpenClaw instance for $3.99 a month.
The use case here is affordable, personal access to powerful agentic models. It democratizes those models, giving you a dedicated agent without the massive enterprise price tag.
Unlike a standard interface where you ask a question and get a text response, an agentic model has utility. It can click, type, and execute a multi-step plan on its own. Having a personal OpenClaw instance means you have an active participant in your workflow rather than just a passive search engine.
Next is Struct. This is an AI agent that automatically root causes engineering alerts.
If you are a developer, diagnosing system issues is a massive time sink. You get an alert at 2 in the morning, and you have to manually sift through thousands of lines of server logs.
Struct analyzes those logs, identifies the anomaly using vector databases and pattern recognition, and diagnoses the root cause instantly. It saves engineering teams hours of manual debugging.
Then we have OpenMolt. This is an open source tool that lets your code create and manage other agents.
If you are building custom multi-agent orchestration, OpenMolt gives you the framework to have different specialized agents interact.
So you could have a research agent gather data, hand it off to an analysis agent to crunch the numbers, and then hand it to a formatting agent to generate the final report, all autonomously.
For web development, there is Framer. Framer allows you to launch websites with complex enterprise needs at startup speeds.
This goes far beyond old template builders. The tool handles the back-end scaling, the component generation, and the responsive design. You are effectively collapsing a month-long development cycle into a single afternoon.
On the marketing side, we are tracking Rainfrog. You use Rainfrog to mix, match, and create stunning, consistent campaign visuals.
The primary use case is streamlined marketing and asset generation. A major pain point in generation is that a brand logo or product style mutates slightly with every new image.
Rainfrog utilizes strict latent space constraints to ensure that every banner, social post, and advertisement maintains exact brand consistency across a massive volume of outputs.
Finally, there is my next browser. This tool makes any browser agentic to automate workflows. It effectively puts repetitive web tasks entirely on autopilot.
Instead of just relying on back-end APIs, it actually parses the document object model of the web page.
You give it a natural language command, and it navigates the web, clicks buttons, fills out forms, and extracts data on your behalf exactly as a human user would.
What is fascinating across this entire list is the rapid evolution from AI as a chatbot to AI as an agent. We have moved decisively from a dynamic where the tool simply returns text to a dynamic where the tool executes operational labor. Struct, OpenMolt, and My Next Browser do not just answer questions. They do the work.
We have covered incredible ground today. We started with massive macroeconomic bets and ended with the specific, practical tools executing those exact bets on a micro level. I want to leave you with the final concept to mull over.
Let's hear it.
We discussed Meta potentially cutting 20% of their workforce to fund infrastructure, believing technology can automate their internal operations. Then we looked at tools like Struct and My Next Browser, which are already making everyday web and engineering workflows fully autonomous for individual users.
The technology required to automate the internal operations of a business is no longer locked inside trillion-dollar tech giants. It is distributing powerful orchestrating capabilities to individual operators and small teams.
So if a massive tech giant is rewriting its entire structure based on agentic efficiency, how quickly will tools like the agentic browser fundamentally rewrite the org chart of every small business?
When an entrepreneur can deploy OpenMolt and My Next Browser to handle their engineering alerts, data entry, and web research autonomously, the traditional structure of a business changes forever. We are entering an era where the size of a company's workforce is no longer the primary indicator of its output capacity.
Thank you for joining us for this deep dive. Follow the podcast and share AI Brief with someone who needs to stay ahead of the curve. See you in the next episode.